Hello, everybody. This is the webinar using historical weather data to help with charter operator negotiations and improving performance from our sponsors, Weathernews. Our guest speaker today is Ben Farig, post-voyage analyst for Weathernews. He'll be answering questions you may have after the presentation, so please leave them in the Q&A section. Here is our host, founding editor of Digital Ship, Carl Jeffrey, to start the talk.
So today we're going to look at advances in how weather data is being used in the commercial side of shipping. So that's supporting commercial managers and charterers as they monitor the decisions relating to vessel performance and weather during the voyage, and also using weather data to help resolve charter disputes afterwards. Because charter parties often have clauses about what people should do if there's a so-called bad weather day, but what constitutes a bad weather day is changing. With climate change, the average wave heights aren't changing so much, but the extreme weather conditions are getting a lot worse. The worst 1% of time at sea is worse than it used to be. And also, charterers are seeking to get more involved in vessel performance decisions, particularly when they involve trade-offs about the weather and the fuel consumption and the arrival time, such as rerouting the vessel somewhere with better weather, but which takes longer. But another technology development is we don't need to rely on weather data reported by the ship so much anymore, which the charterers might not trust, because weather companies like WNI can provide very accurate historic weather data for every part of the world at any time. They've got much more weather data sensors, including on satellites, and better forecasting capability to fill in the gaps. So that provides data ship owners and charterers of data they can both trust when they're making decisions about the vessel routes and speed during the voyage. And the data can be used if there's any disputes to resolve afterwards, such as whether the ship really did have a bad weather day. We're going to hear today from Ben Farig, who's a post-voyage analyst with Weathernews based in Oklahoma City. It's not a maritime center, of course, but it's a major center for weather forecasting. It's home of the US National Weather Center and one of the largest meteorology schools in the US. And Ben currently works as a post-voyage analyst, helping resolve weather-related disputes between owners and charterers. So Ben's going to give a talk of about 30 minutes, then we'll take your questions. You can put them in the Q&A box at any time. And I'd like to invite Ben to start the talk.
Well, thank you very much, Carl. Thank you for that introduction. As you mentioned, yes, my name is Ben Farig at Weathernews. I'm located in Oklahoma City, Oklahoma, and it's basically in the middle of the country. Not too far from Texas. I think probably a lot of people are familiar with Texas, so we're not too far from the Texans. I've been with Weathernews now for over 20 years, and for the first 10 years, I worked as a voyage planner, risk communicator, working in different roles in that regard, planning voyages. For the last 10 years, I've been working as part of our official performance auditing team, and we are analyzing performance as it relates to charter party agreements. So as you might guess, I'm very interested in historical weather and sea analysis, and that's what we're going to focus on today. Historical data is basically observational and analysis data that's constantly obtained and saved, and it offers a lot of benefits. It offers reliable analysis, right now, or even analysis from the past. When I'm referring to historical data, I'm referring to data from 3 years ago, 3 months ago, 3 days ago, 3 hours ago even. So reliable analysis is very helpful from historical data, and that can lead then to improved forecasting, right? Because forecasts begin from an accurate analysis and accurate understanding of what's going on in the world's atmosphere, in the world's oceans. And from those improved forecasts, we can develop actionable insights regarding vessel performance, conditions at port, what have you. This helps us enhance accuracy, predicting voyage times and fuel consumption. It also provides critical evidence for resolving weather-related disputes. And we think it has the potential to further strengthen charter operator, charter owner negotiations for fair outcomes. At Weathernews, our big thing is quick and fair. We want to provide fair insights, fair assessments about how vessels perform, be it against a charter party warranty or be it in regards to emissions, etc. Disputes, as many of our audience will understand, take a lot of time. It's a lot of back and forth between parties. It can be damaging to business relationships. At Weather News, our view is we want to not just help resolve disputes quickly and amicably, but to try to avoid them in the first place. And we think that relying on historical weather data, historical ocean data, can help us in that regard. You know, can we develop an understanding of how vessels are expected to perform even before the voyage? So that way we can kind of follow up during the voyage and monitor how things are going and take frequent looks back into performance along the way. These possibilities exist thanks to ongoing collection and analysis from historical data. You know, we can see, has the vessel performed as expected? And if she hasn't, why not? So we can use historical data to have these ongoing discussions and negotiations even before a vessel arrives. You know, we kind of sit back and we say, why wait until after a voyage is completed to have these discussions? Why wait until we receive reports from weather routing companies, you know, assessing performance to start these disputes? Let's go ahead and let's try to get ahead of that. And so, as I mentioned, I work in the performance, the official performance auditing team. So I'm a CP terms kind of guy, right? We work with charter party clauses. We look at good weather descriptions a lot, and we're really interested in published London arbitration awards. Awards that are published that deal with performance claims are extremely interesting to us. And we think that in recent years, there are some trends we can pick from awards as it relates to historical weather data that is useful. That's worth mentioning today, in fact. This slide lists 4 key awards. It's not all the awards that have been published in recent years, but it lists 4 key awards, and they go back to 2021. The first award listed here is from 2021, and the 4th award actually was just published out of London a couple weeks ago, September 27th, towards the end of September. So it's a fresh award, and it's a really interesting award. If you have time to check it out, I suggest you do. It's full of very interesting and we think useful information. What trends from London arbitration have been suggesting is an increasing relevance of accurate historical weather and sea data when it comes to resolving disputes. Of course, when something goes to arbitration, it's a dispute that hasn't been resolved, right? And so the role of the arbiter is to try to resolve this dispute. And what we've been seeing is use of historical data. Traditionally speaking, Carl kind of referred to this earlier, the records from deck logs have been maybe the preferred source of weather and sea evidence by London arbiters. What we've been seeing from recent trends in London arbitration is a willingness and sometimes even a preference to not just consider, but also utilize the analysis of weather routing company reports. In some cases, the arbiters have used the weather routing company analysis to even identify suitable steaming days from which to kind of derive their own performance assessments against different clauses of the charter party agreement. These trends by no means suggest that the records of the deck logs shouldn't be given due consideration. Rather, in our view, we think the recent awards indicate that the records of the deck logs and the analysis of the weather routing companies should be compared side by side to really understand the trends of each source, maybe the reliability of each source, you know, in a way kind of acting like checks and balances on one another. So another thing to consider too with the weather routing analysis, at least when it comes to live discussions during a voyage, is that many of us only receive one report from a vessel each day. We receive a noon report. And that noon report is usually packed with a lot of useful information. And some of that information includes weather and ocean analysis, winds, waves. Sometimes there's a remark about ocean currents. But we only get that one snapshot for the day, don't we? And oftentimes that is representative of the conditions encountered right at noon. Analysis from Weathernews offers 3-hourly or even at times 1-hourly output if we have hourly vessel positions to compare it against, from which we can, in our view, paint a more thorough picture of the conditions being encountered by a vessel. And this all stems from the use of historical data. So what can we learn from arbitration awards such as those listed here? Well, we can see that tribunals will give due consideration to the weather and sea analysis from weather routing companies. Tribunals will compare weather routing analyses against deck log observations. Tribunals can prefer the weather news analysis to deck log observations. And in some cases, in some cases, arbitrators might even use historical weather analysis to calculate their own assessments in terms of time loss and fuel overconsumption, if any. Similarly to how a weather routing company might output such an assessment. The methodologies may be different, but it's kind of a similar overall conclusion. Okay, so historical weather data is being used by London arbitration. In our view, what that means is that all parties can make use of historical data in order to understand performance trends, right? If this data is being trusted and relied upon in London arbitration, then it's becoming more and more trustworthy, and we can use it for other means during discussions. And we can also use it to assess performance outside of normal, what you might consider charter party methods. We can consider historical weather and sea data during what we might call the bad weather days, right? Maybe for a voyage, maybe 15 or 20% of the voyage is good weather, 80%, 85% of the voyage is bad weather. We would like to understand how that vessel is performing during the bad weather periods as well. Historical weather data enables us to do this. It allows us to take a closer look at vessel performance against Weathernews analyzed conditions and also new reported conditions. And what we're looking at on the slide here is an output from the Weathernews Sea Navigator platform that is available to our customers and supporters. And what it is showing is it's showing the Weathernews analysis as a blue line. It is showing in the top graph the wind conditions as reported from the vessel's noon reports with an orange bar. And that middle graph is showing wave conditions, and the orange circles represent the conditions reported from the vessel's noon report for wave conditions. Let's take a closer look at that graph. For your reference, in the background, the gray shading represents bad weather periods, and the light white shading represents good weather periods. So we're looking at a lot of information during the voyage, inclusive of all weather conditions. And we can immediately pick out trends in terms of how the Weathernews analysis is seeing conditions versus what's being reported from the ship. We get a sense for direction of the conditions as well. The red lines on these images reflect the charter party good weather thresholds in this case. So that top chart is showing wind conditions, and that red line represents Beaufort Force 4. And then the wave chart is showing a 2-meter wave height threshold. I've included here a purple box to identify some good weather days that Weathernews has analyzed during the voyage. You can kind of see here, well, some parties may wish to kind of hone in on this. They may wish to focus on just the good weather period rather than some other bad weather periods. And in this case, we can see that we are finding the vessels reporting kind of similar wind conditions really during the good weather period, but we're also seeing that the wave threshold is a little bit above that good weather threshold during the good weather period. So if parties observing this during the voyage have questions about performance, they may wish to identify these few steaming days and really kind of drill into that, contact Weathernews, discuss with their other party about what's going on during these days specifically. But we can also consider, like I said, the bad weather days as well. In thinking on this and preparing for the webinar, I came back to a topic that I often think about, and that's that weather conditions aren't created equal. And I think in terms of a wind of 17 knots. A 17-knot wind is a Beaufort Force 5 wind. And when we're considering bulker vessels, that's typically a bad weather threshold. But for anyone in the audience who's ever been on a jog or gone cycling or been sailing, a 17-knot wind right on the nose is completely different than a 17-knot tailwind to your back, right? If I'm jogging and I have a 17-knot wind to the back, it feels pretty good. But if I'm running into it, it's terrible. The same may be said for vessels. If a vessel's been sailing under winds of about 17 knots, 18 knots throughout an entire steaming day, and it's a bad weather day, but the wind has been following, from a charter perspective, perhaps they could raise a question. Well, if the tailwind is 17 knots, she should be gaining a benefit. The vessel should be gaining a benefit. Why is she underperforming by a knot on this day? And look into other, environmental or vessel-based specifics that might be causing any such delay, or underperformance. So here, comparing the Weathernews analysis with reports from a vessel's noon reports can be useful, we think, for parties trying to resolve or really get ahead of disputes. And it all comes down to the historical data that's being leveraged in this case. There are maybe some novel things that we can do, or, I say novel, but in some ways, maybe that they've been done for a while, but they're packaged a little bit differently now. We can use historical weather data to run different good weather settings, or even different charter party settings, charter party speed and consumption settings against the vessel's actual performance after a voyage is completed. And we see this requirement actually from charters and owners. And this concept was kind of born out of requests from our customers, charters and owners, to receive not just voyage audit reports after a voyage, but reference reports to look at different conditions. So historical data can be used to see what the damage might have been if a vessel's good weather description was relaxed. Would there have been a savings of fuel oil consumption if the daily IFO rate was reduced from 25 metric tons to 24 metric tons? Oh, what would have happened if instead of applying minus half a knot for the speed about, we applied minus 5% for the speed about? Or what would the assessment be if we looked at all weather days and didn't filter out good weather days? What would the performance assessment look like then? These types of insights we think can be useful for charters and owners, and at the push of a button. I'm going to go ahead and go to the next slide here where I zoom in a little bit on this concept. And what you're seeing here is this, again, is output from the Weathernews CP simulator module in our Sea Navigator platform. The column on the left side reflects the performance assessment based upon the agreed charter party terms. And so this would basically be the assessment you would see from a voyage audit report developed by Weathernews. The column on the right utilizes the same historical information as the column on the left, but it has applied a relaxed good weather wave threshold. Instead of 1.25 meters, we're using 2 meters. And it has removed any consideration for adverse currents when identifying good days. So we can see by changing these two things a little bit, relaxing the good weather threshold overall, we arrive at a larger good weather sample size. And we're actually seeing a little bit of an increased time loss assessment from about 19 hours to about 22 and a half hours. Well, great. So that's looking backwards. Can historical data help us understand what we might expect going forward? Yeah, in some regards it can. As Carl mentioned earlier, we're seeing more severe storms across the world, right? Our planet is changing, and we're seeing increased instances of the more severe conditions associated with these storms. Historical sea data confirms that we are seeing these greater instances of severe wave heights. On the right side of this slide, we see two global images. The global image on the top right is showing average significant wave height across the world. And you might see too much of an anomaly here, but if you look at the global image on the bottom right, this is representing the 99th percentile significant wave height across the world. In other words, the incidences of maximum wave heights are increasing. We're seeing more severe conditions when they are truly severe. We can glean this from the historical data, but it needs to be useful. What can we use this information for? What is it telling us? Well, it's telling us ultimately that voyages are getting longer. The image in this slide is showing voyage distance in the blue bars and voyage time represented by an orange line across the North Pacific in recent years. And what this is showing is an uptick in voyage distances, right? And we're seeing, a correlating uptick in voyage time. So historical weather and sea data is showing us that the changing climate is causing increased incidence of severe weather. It's leading to increased voyage distances and time. Vessels are spending more time at sea. This means more emissions, right? And we need to keep this in mind because there's an increased focus on a greener planet, on reducing emissions. The shipping industry is kind of taking a lead in this regard with a lot of the regulations that have been going into place and that will be coming into place in 2025. So understanding this trend is important too, so we can try to find ways to reverse it, shorter voyages, less time at sea, or fewer emissions. I think this finding could also imply that claims along such voyages may become larger. If there is a good weather assessment to be made, in attendance will understand and appreciate that the good weather method is typically what is used to assess vessel performance. And the final step in that assessment, in that process, is the quantification of damages. It is extrapolating that good weather performance across the total voyage distance. So if we're extrapolating good weather performance across a longer voyage distance, we're going to see a larger damage assessment. So this information is based upon findings derived from historical data. And again, this really underpins, in our view, the importance of such data. And we want the data to be as trustworthy and robust as possible. So how can we ensure that we're continuing to collect and utilize the most reliable information possible? And one of the ways that we can do that is by enhancing the network that's used to observe and analyze weather and sea information in real time in order to maintain a better understanding of conditions encountered by a given vessel at a given time. So let's take a look at some of the methods that are traditionally utilized to obtain weather information. The data collection and quality control ultimately is the constant accumulation, collection of historical data. And the denser the quality controlled observation data, the better the model initialization. That's the model initialization is basically the understanding of the current atmospheric and oceanic situation. The better that, then the better the forecasts we can develop, which means the better voyage time estimates, voyage consumption estimates, emissions estimates, and also we think hopefully chances we have at not just resolving disputes, but avoiding them. The image here on the slide, the little squares are representative of methods used to collect data, and they're feeding into the W&I logo. It's kind of the W&I engine, if you will, the W&I database. And you'll see that the top left image represents a satellite. And indeed, satellites are used to collect data. Satellites offer us tremendous insights ongoing across the globe. And satellites, because they're constantly moving with the planet or along the planet's axes, provide over the course of a day a much wider span of analysis than we can obtain from just vessel reports and land-based observation networks. That said, there are other things that we utilize to ingest data. Weather satellites aren't the only things used for this purpose. Land-based weather networks, for example, being located in the US, I think of the National Weather Service offices in this country. There's over, I think, 120 or 130 of them. They launch a couple different weather balloons every single day. So we get real data about the atmosphere from those kinds of networks. We also have vessel reports. We have vessels that participate in the voluntary observing ship program that are providing reports on a daily basis. We have buoy networks that we rely upon for wave analysis, what have you. So all this data then gets fed into an analysis. And because we're able to collect more and more and more of this data, we're able to improve the resolution of our analysis and our forecasts. That image on the top right of the slide reflects significant wave height, and it is showing a 0.125 degree grid. It wasn't that long ago where the grid size was 1 degree by 1 degree, a much larger grid. But now we have shrunk that down to 0.125 degree grids, so we can see closer to the vessel level what is going on. And as the image on the bottom right of the slide shows, this also allows us to reduce the error in our analysis and our forecasts across the world. In terms of the data that we're collecting, I mentioned that we're able to get a finer resolution because of the amount of data. The amount of data is copious. In terms of data obtained from vessels, W&I is able to utilize from over 6,500 voyages or voyage segments per month, data that includes more than 600,000 emails, more than 300,000 ship reports each month. And we're also combining this with AIS data. Most of the audience, I believe, is familiar with AIS data from transponders on vessels. We're receiving over 300,000 data points per day because we can receive AIS information from, I believe, something like 70,000 vessels every 2 to 10 minutes. So it's a tremendous amount of data that we're ingesting into our systems. And we're able to do that increasingly efficiently by utilizing things such as the cloud and machine learning. So going back to the data collection and enhancing the sensory network, if you will, in order to avoid and resolve disputes, we need to improve the data collection. This is achieved by closing data voids across the world. And by data void, I think the audience can see that in the top right-hand side of the slide, what we're showing is reports from NOAA vessels, that voluntary observing ship system. And it's great. We see a lot of data collection from crews that are trained on taking observations, etc. But there's a lot of voids across the world, right? We can improve that by utilizing reports from vessels that are sailing under Weathernews services. And if you look at the globe on the bottom right-hand side of the slide, the red dots represent the observations from ships under our services. And these vessels, as you might expect, are sailing along traditional routes, common shipping lanes. You know, you think of something, say, the iron ore trade from Northwest Australia to Eastern Japan, vessels going up and down along that trade. We're collecting data constantly from those vessels, and we're able to ingest that and apply bias corrections in order to utilize it in our analysis, our historical data, and then our forecasting. The images on the left side of the screen, well, the one farthest left to the bottom left is it shows the coverage of weather satellites that I mentioned before. And I think this stands out because it helps to fill in a lot of the voids I mentioned before because of the coverage of the satellites. In this case, this image is reflecting the output of 5 weather satellites, 5 of the weather satellites that Weathernews is ingesting data from on a daily basis. So the point here is that we're closing the voids and we're collecting more and more data. And we're able to quality control this data in order to utilize it in our historical databases, which can be used then to help avoid disputes. Hopefully parties can see this data, this information as trustworthy and robust and worthy in order to close disputes, to avoid disputes even. Another thing that is utilized in order to improve data, data processing methods contribute to the reliability of the analysis data. This can lead to more accurate forecasts and better predictions of vessel performance. All observation data and worldwide forecast model data is compiled and processed throughout internal forecast systems in order to generate relevant output. Machine learning techniques, some utilization of AI are applied to compare with actual observations in order to constantly sort of fine-tune the analysis forecast methods. And these techniques allow for an increasingly fine resolution of analysis and forecast information. I referred previously to kind of the trying to scale down to the vessel relative size. This image on the slide is showing the Mercator ocean current output. Daily noon reports from a vessel will often include a remark about ocean current data, but the remark is usually a little vague. You know, it might refer to general direction, be it favorable or adverse. It might refer to the magnitude, maybe half a knot of the current effect, but it only gives us one snapshot, one kind of general idea for the day. Well, let's utilize something like this Mercator ocean current data, which could be available on an hourly analysis output. Let's couple that noon report observation data with something like this high resolution ocean current output, because then we can better understand what the vessel is encountering during a steaming day. And this can be especially useful in regions of strong current cores or even current eddies, where a vessel is kind of sailing across the eddy during a steaming day. The Weathernews analysis or the fine scale analysis here can pick up on any changes that the vessel is encountering in terms of direction and strength. So reliable ocean current information can be used to inspect and understand a vessel's performance. And we believe that improved output such as this will help parties actively discuss ongoing questions related to performance. Hey, the currents encountered today were 1 knot favorable. Why wasn't the speed also 1 knot favorable, etc. And focusing on trying to really get down to that vessel level detail, where a lot of analysis was once rather coarse in terms of historical data even, we now have fine scale resolution analysis data. And this is possible from improved remote sensing and machine learning techniques, but also from proprietary sensory networks, such as we discussed before with Weathernews ingesting vessel observations in our network that are under our services. Such improvements, you go from a 10-kilometer grid all the way down to this 1-kilometer grid, and in some cases, we're even going down to, say, a 10-meter grid. Now, I should comment here that this is experimental output, but we wanted to show today about what historical data can do potentially. In the slide on the top, the image on the top right, what we're looking at is two different loops for the same area. The loop on the left indicates that much of the region being analyzed here, the wind speed would probably be analyzed around 6 to 8 knots or so for most of that square. But then when we go to the right and we consider individual buildings and how wind is acting around those buildings, we can see that there's a larger area where the wind, maybe it's only about 4 or 6 meters per second. And we can identify and really highlight the areas where the wind is heavier, maybe 6, 8 meters per second, 10 meters per second. The image below on the bottom right of the screen represents something a vessel might encounter going into port. In this case, the little yellow image represents the vessel. And as a vessel sailing to port, what that large orange arrow is showing is what we might have previously analyzed as the vessel encountering, a southwest wind of about 10 meters per second. But by using this fine mesh, accurate, reliable, trustworthy historical data, we can improve the analysis so that we see, okay, the vessel is encountering 10 knots, 10 meters per second, it became 8 meters per second. In between buildings in that channel, it increased to 15 meters per second, and then it relaxed to 5 meters per second. There's a lot going on a short amount of time here. And so the collection of this sort of information we think can be useful in this particular instance. We think maybe it could be particularly useful in regards to berth waiting times and port operations, scenarios that can lead to disputes maybe between parties regarding lay time and demurrage. So keep your eyes peeled. This kind of output, in fact, it's being developed for drones as well. So this kind of output offers a very promising glimpse, we think, into the future. And I've been going a little bit long here. I apologize for that. I have a few more slides. I want to talk about predicting voyage and fuel consumption and kind of going beyond traditional performance assessment. And one of the ways we can do this is with cost-based analysis. And we can also do it with emissions-based analysis. All this is possible through historical data. The historical data introduces, for example, what we refer to as the minimum voyage cost solution. And under this solution, all available RPM ranges may be simulated against multiple routes to instantaneously calculate the most advantageous combination for a given voyage. The reliable historical data and analysis enables accurate forecasts to be made, right? So we can combine that with historical information related to the vessel's performance, even on a vessel-by-vessel basis, in order to accurately estimate against a multitude of RPM settings against many different routes across the world. And looking at this example, we're looking at kind of a common situation, the image on the far right, where we have to make a decision. Should I go north of the UK or south of the UK in order to get to Northern Europe? Being able to simulate with historical data against multiple route options at multiple available RPM settings can maybe, reduce the need for any charter party based routing for this voyage. Maybe the charter decides, okay, I can better kind of hedge my costs by forgetting about the charter party warranted speeds. There's only a couple of them, and instead leveraging all the RPMs, the entire RPM range, in order to make the most of this voyage. Historical data makes these kinds of things possible, and it also makes emissions calculations more reliable and trustworthy, which becomes very important. We have new regulations coming into play in 2025. So improved historical data will promote more accurate estimates of emissions along a given route, which obviously is critical when trying to reduce costs as they relate to emissions. And just two more things I wanted to point out, if I may please, today is leveraging technological simulations and data visualization based on historical information that's available to us. And I mentioned port delays a little bit earlier. Historical weather data may be combined with historical AIS data to gain further insights on trends that might affect vessel operations, particularly at port. What you're looking at on the screen here is a product that's under development with Weathernews through support with our customers, we refer to as our supporters and our partners. It's called the Berth Waiting Forecast Module. It's available through our Sea Navigator platform. And what it allows parties to do is anticipate port congestions and delays ahead of time, which can improve their decision making, right? If you have a vessel sailing to a port, based on your schedule or cargo needs, do you need to speed up? Do you want to slow down? Should you continue competing with another vessel for position, or should you back off? Should you consider an alternate port? Are, we think, very meaningful and hopefully helpful insights that will be available to parties, hopefully to resolve or avoid disputes. In addition to insights gained regarding conditions at port, historical data can be used to understand vessel past performance. Now, that may be obvious, but what I'm referring to in this case, historical AIS and weather information may be used to understand how a vessel has performed historically against user-defined good weather terms. And so another module that Weathernews is in the process of developing, again, with our supporters and collaborators, is something called a new tonnage finder, which compares a vessel's past performance via AIS data against analyzed conditions. What the user can select a vessel, a time range, and a good weather criteria, and display how the vessel performed, where the vessel sailed, and how the vessel performed with those criteria. It's another kind of plug and play scenario that's available to our customers. And this product can be helpful in several scenarios, such as reviewing the trends in a vessel's performance. Does the underperformance assessment of a weather routing company report make sense for a given load condition in good weather setting? Or it could even be useful for vessel fixture in the future. Does it make sense to, fix this vessel or that vessel? Again, in an effort to try to get ahead of disputes. We've actually seen this application be useful when a charter was deciding whether or not to pursue a claim in regards to a vessel that was not under Weathernews services. The customer wanted to understand the vessel's previous performance against weather conditions that were being encountered, was able to utilize this product, and was able to ultimately decide that no, it was not worth pursuing a claim in that specific case. So what we've gone through today is historical data and how it forms the bedrock of all analysis and all forecasts. And no matter how far we come with machine learning and AI methods, you're only as good as the information that's fed into it. Quality in means quality out. And so at Weathernews, that's what we're striving to ensure to everyone, trustworthy data. The need to utilize numerous sources of data is evident. More and more data can be used to glean, to make more and more findings, to develop more and more insights, and improve data collection and analysis methods. Again, with the improved network around the world, leveraging machine learning and AI techniques, we can develop a better, more robust database of historical data. And so with that, Carl, I turn things over to you.
Well, thank you very much. Well, that's great. So we'll go into the Q&A session if you want to stop the screen sharing. So we've got 3 questions come in so far from a gentleman called Alistair Rove. So I've just looked you up on LinkedIn. Alistair, I can see you're Principal Master Mariner with Brooks Bell, which is consultancy, and your former marine vetting specialist with Chevron, and former master with BP Shipping. So I don't understand your questions, but I'm sure Ben will. So the first one, Ben, have London arbitrators or the High Court accepted your performance assessment outside good weather days, or where there is no good weather during a voyage?
Interesting question. Honestly speaking, let's refer to weather routing companies in general. The short answer is no. To the best of our knowledge, in published arbitration, good weather has always been required in order to assess performance. There was an award from, I believe, 2012, where a weather routing company was able to apply a weather factor and a current factor in order to quantify the damages, but that was done after a period of good weather was found first. Now, I would like to, this is an excellent question, so thank you. I would like to comment on the Divine Gate ruling from August of 2022 from the Commercial Court. It was a fundamental ruling. It was critical to all of us in the weather routing company. Among other things, it told us how to handle the treatment of positive currents. And in that ruling, the judge, she referred to the fact that it is possible to assess performance by methods other than the traditional good weather method. She also said that any such methodology would need to be reliable and consistent. And that she basically inferred that since the good weather method has been around for decades and decades, and it's been used so reliably, in cases where good weather is available, that perhaps that's kind of the go-to method. But it's been acknowledged, again, in the commercial court and also in some of the literature, that there are other methods. How exactly to develop them and convince tribunals and judges to accept that, I don't know if we're sure. Does that answer your question, I hope?
Yeah. So the charter party says this is what happens in good weather, but if it's bad weather, you've got other things you can do. And
Right.
yeah, but it doesn't sort of have a radiation
Well,
between them. Yeah.
yeah, you know, and tribunals, of course, they will consider all the relevant facts. And so, and Carl, actually, I think you and I may have discussed this very briefly before today's webinar. There are rulings out of New York from a longer time ago where periods of bad weather were accepted during good weather days. You know, the example of having a tailwind. Well, if it's a 17 knot tailwind, is it bad weather? Is it not? Can we accept it? It seemed like the rulings out of New York were more willing to accept that kind of an argument. Honestly, recent trends in London arbitration, I don't really think they've seen it that way. You know, we have to apply the terms of the charter party agreement because that's what was agreed.
Very good. So second question from Alistair. How do you know the surface current information used for a current factor is a true representation of the current that the vessel encounters, especially those of different drafts? Didn't know.
This is another good question, and honestly, something we're asked a lot. And quite frankly, it's a challenge. A lot of the ocean current information is derived from analysis from satellites. We're able to measure temperature, salinity, et cetera, of the ocean. We can couple that with ocean buoy networks in order to understand the nature of currents. Obviously, you apply physics, et cetera. But you know, during the discussion, we mentioned voids and data, and so that's one of the challenges with that. And you know, actually, as I recall, a colleague of mine, well, our operations manager, Amy Buell, recently gave a presentation at the IMO a few weeks ago, and she discussed this issue of ingesting, you know, data from ships at sea, et cetera. And one of the questions was about ocean currents and ocean currents at different depths, and what can we do to improve that. And so I think improving the Sentry network is one way to do it. It's a bit of a tricky business in terms of the vessels and draft. This is where we get into discussions about charter party agreements and terms maybe being vague. When you say no adverse currents, are you referring to ocean surface currents? Are you referring to currents 15 meters deep? What are we talking about? So as we tell most of our customers, if you can clarify your charter party terms as much as possible, it helps everybody. It helps everybody. It helps, you know, Weathernews create a better report, a more accurate report in line with the thinking of the contracting parties. For the time being, our understanding is that when we see no adverse current, we're talking about the surface currents. You know, in terms of how do we know it's accurate, we can compare with buoy networks, et cetera. A lot of those are usually closer to shore side, so it becomes more challenging across the open ocean, admittedly.
Wow. Yeah, I didn't even know currents were different at different depths, but that's so good. Third question from Alistair. Given that similar vessels will perform differently because of different loading conditions and autopilot settings, how can you accurately predict vessel performance in significant wave conditions at different revolutions per minute of the engine? Well, that's what models can predict anything, whether accurate or not. Is it? Yeah.
It's right. Like, yeah, I can post anything online, right? Yeah. That's another excellent question. Well, a lot of that comes down to having a background knowledge of the vessel, doesn't it? A lot of vessels under our service, we are providing route assistance for numerous voyages. So we're collecting a lot of data from that vessel, which allows us to enhance a parameter in order to predict its analysis. You know, we apply a lot of different kind of statistical methods, machine learning methods in order to anticipate how a vessel is going to perform, certainly at different drafts, different types of vessels, vessel specific at different speeds and RPMs. And this all requires that accurate background data that we have on the vessel, that we have on analysis data, on forecast data. There is one element that I would point out that is an unknown, and that's the human element. You know, one master may do things a little bit differently than another master. You know, we see that from the observation of data as well. Carl might see a 1.5 meter wave. I might see a 2 meter wave. So differences between human beings also can kind of play a role. But to answer your question, it really does come down to the background data and the simulations that we can then run based on what we know the vessel has done in the past.
Oh, very good. So now you've got a question, I think, from a competitor in Germany, David Boxall from Waveforce. How do you deal with the master's reported fuel consumption a day? Are there any checks to its accuracy? I don't know if you're dealing with fuel consumption data, are you? I don't know.
We are, and hello, David. It's nice to hear from you. Yeah, we do. We take in the fuel consumption per day, but that is on a daily basis, right? So that's all that we have available to us. We can compare that to, again, the conditions encountered and what would be expected for the vessel to consume at that RPM. But there are different things to consider. Maybe the master is trying to reduce consumption for the day at the cost of speed, or vice versa. More companies are interested in sensor data. Actually, it's kind of become a hot topic lately, kind of like AI was a hot topic, and big data is a hot topic. Utilizing sensor data in order to measure that more accurately is also a hot topic. But in terms of fuel consumption, one of the things we try to always look at is to compare with the daily average RPM settings. And again, here, where we have one new report a day, it would really be nice to get all 6 deck log records for the day in order to compare this, because sure, a vessel might consume 24 metric tons a day, but that's probably not being consumed at equal amounts throughout the day. When the vessel's encountering a stronger adverse current, she may be consuming more fuel than she is when that current kind of relaxes. So to answer David's question, we're using the reports that are given to us from the vessel on a daily basis.
Yeah, very good. Well, a question that crossed my mind. So there's a big change in how shipping industry is running with this high resolution data. I guess the industry is used to working in a certain way, developed over decades with a weather forecast and then negotiations. But now, I mean, you're basically simulating the conditions of the vessel as it comes in. Another 3 questions just came in, actually. So maybe I don't know, but this is a very different change to shipping we're about to see, I suppose, isn't it? So, yeah.
Yeah, I think so. And I think it's a good change. I mean, from my perspective, just speaking frankly off the cuff, it's very, very cool stuff. Because of what we can do, because we're not limited with like a computer server, a cranky computer server that we have to change out or reload or whatever for whatever need, and it's all rooted in the cloud. We're able to pull simulations constantly all the time. And that's getting better and better and better. And being able to simulate more of this data like this just gives us deeper insights into what's going on, what has happened, and what we predict will happen. Yeah.
Oh, very good. So we're going to Dubai now. So Captain Novanil Sinha Roy is the Senior Vessel Performance Manager with Oldendorf Carriers. Typically, how accurate is the speed loss estimates in different weather conditions?
Hello, Captain. Thank you for your question. The speed loss estimate, I don't have any figures off the top of my head. We would need to kind of dig into that and get back to you. And again, here it's very vessel specific, even very vessel type specific. Thinking in terms of laden tankers, where we've seen tremendous drops in speed depending on the conditions being encountered, versus bulkers. But then the vessel age plays a factor into this. So honestly, there's many different variables that play into it. So it's difficult to answer that question with one variable. Unfortunately, off the top of my head, we would need to discuss that with you further.
Oh, very good. Okay, so now we're going to Athens, Stavros, Michaelidis. Most of ship performance models are using specific vessel hydrodynamic characteristics, such as from towing tank resistance experiments. Are you following the same approach on a per vessel basis? I've missed out a bit of the question there, but I think you can see it about different.
Yeah. So sure. Yeah, we're applying different methods, and we test out different methods to see what is more applicable. We're applying statistical methods, and we're also applying naval architecture methods as well to our estimates. I should be upfront here saying my background, I'm a weather guy. I'm not a naval architecture guy so much, so I'm probably limited in how much I can answer your question. But we are using naval architecture methods in our simulations in order to understand to predict how a vessel may perform in given conditions.
Oh, very good. So now we're going to Captain René Hansen, who's with Maersk in Denmark. relying on manual observations in new reports, how do you ensure the data is correct? The wave
Yeah, it's a
height
great
can be.
question. Yeah, good question, Captain. We apply statistical and bias techniques in order to ensure that we're ingesting correct information. If we can understand bias and we can understand the error by comparing to other nearby vessels or satellite measurements, etc., we can arrive at an accurate observation from that vessel. So those kinds of comparisons are utilized in order to make sure we're ingesting good data. That's a fantastic question, because like I said earlier, quality in means quality out. So you can't just say, hey, I've collected 10,000 reports and dump them into the simulation. It doesn't work that way. So that's how we do it.
Yeah, he's talking specifically about the challenge of measuring wave height from the bridge and looking down 55 meters. Crikey. I guess there's a,
You know, that's a great point. That's a great question. We have a lot of discussions internally about that as well, because charter party agreements, as you might know, oftentimes they will require a 1.25 meter significant wave height as a maximum threshold, or 1.25 meter wave. Oh goodness, from 30 meters up, how do you differentiate between 1.25 meters and 1.3 meters, right? And so that's where utilizing maybe multiple vessel reports, data from satellites, is very, very helpful. It's instrumental, no pun intended, in solving those problems.
Oh, very good. So George Sevdos, General Manager of Plutofax Shipping Corporation in Greece, do you take into account the effect of wind friction over the sea surface in calculating currents at sea?
Yes, wind friction is accounted for certainly in the ocean current models and the ocean current analysis. I mean, because it plays a critical role in the effects of ocean currents. So yes, surface wind is accounted for in the ocean current model calculations.
Oh, very good. Well, another question. Oh, go David Boxall again. Oh, how high are your satellites above the Earth? Can they really be accurate to 0.05 centimeters? I don't think you said 0.05 centimeters, did you? But
No, I don't think I gave a value, but I did talk about the grid in terms of degrees. Different satellites, you know, are circling the Earth at different altitudes, and some of them are moving in different directions. And so again, by understanding the error involved in the data collection process and the analysis process, corrections are able to be applied to the outputs. And you're also able to identify, and you can see this on the ASCAT website as well, that a lot of people use. You can identify when there are outliers that need to be dismissed. So you utilize bias, you understand error, and you can use that in order to ensure a greater accuracy of the satellite data.
oh, very good. And another question that occurred to me, where do we see the relationship between charterers and owners going as a result of this? Is it going to get more complicated because charterers can see more data, or do you think disputes are going to get resolved more easily? Or maybe it's more a philosophical question. But
Yeah, well, I mean, we certainly hope that they don't even exist. And, you know, I mean, there are certainly, what we've heard from some charter customers is that they would like to monitor performance more on a daily basis party requirements. They want to try to get away from the charter party method, and they want to rely more on RPM settings, fuel consumption speed on a daily basis, emissions calculations, in order to minimize cost rather than relying on maybe recouping some costs later via a performance claim. So that's what we're hearing from some charters. Now, the shipping industry is notorious for being a bit of a slow mover in this regard when it comes to charter party agreements, you know. So we'll see what happens. We've been talking about this for a long time. But I think a lot of us here at Weathernews would encourage parties to explore other methods for trying to reduce costs during voyages. You know, one example is if you have a long voyage and a vessel's been sailing for 3 or 4 days and her speed seems to be pretty reasonable, maybe we consider for that voyage switching from a CP compliance kind of method to that minimum voyage cost method that I mentioned earlier in the presentation, where we try to optimize the RPM based on the forecast conditions along the route. We think we can save more in terms of cost, fuel, emissions through that approach than by utilizing the charter party method, where you may only have a few select settings. But we'll see. we'll see. It's difficult to say. Like I said, shipping moves a little bit slowly in this regard.
Yeah, very good. So question from Captain Hansen from Maersk. When generating your advice, are you providing main engine power advice or speed advice? I don't know if you are providing advice about speed or power, are you?
Well, we're generally providing advice for RPM settings. We can
Okay.
provide it for speed settings as well. And there's usually a calculated consumption assessment that goes along with that. But we're focusing primarily on RPM, which obviously derives from engine power.
Oh, very good. Yeah, well, it's a fascinating story. But I guess weather data is the main source of uncertainty for shipping. It's not the only one,
Yeah.
but it's probably the. And if we're taking some of this uncertainty away, then that's So Stavros Michaelidis, statistically, how accurate are the last 10 days of the 30 days forecast you provide compared to the actual weather data? It must be the next 10 days, I think he means, doesn't it? Or, you know?
Yeah, sure. Well, the next 10 days, you kind of look at it. I'm going to speak honestly here as a meteorologist. When you're looking at forecasts, really that first 3 to 5 day range is going to be your most accurate, right? A way I like to, it's kind of a simple way to explain it, but the way I like to explain this to my friends and family anyway is think of you trying to solve a math equation and you put a minus sign in the wrong spot somewhere in the process. That error is going to compound throughout the entire process, right? So the farther you go out in a forecast, 6 days, 7 days, 10 days, the more likely you are to see things change, basically. I don't want to say things are wrong because forecasts, what they're meant to do is offer a risk assessment, right? Of what could happen so that we can plan what we should do based on that risk. Once you get out beyond about 5 days, it gets a little more variable, honestly speaking. It's gotten better, I will say. I have been very surprised in the last 5 years at how the forecasts have improved at that long range. But traditionally speaking, the first 3 to 5 days of a forecast are going to be your more reliable.
Yeah, I mean, forecasting, I guess people used to think that was what weather was all about, but we barely mentioned it. But I suppose that's. But I was very interested in the CII simulator because there must be a lot of companies thinking, oh, I've got to get this score by the end of the year, and being able to predict, taking weather and conditions into account. I suppose that's very useful. I don't know, but that's the whole year of predictions.
It is. Yeah, it's super useful. I mean, ultimately, what are we talking about? We're talking about predicting the future, right? It's a tricky business, but it's a fun business.
Yeah, and it's getting easier, even if it's not not solved yet. But yeah.
Yeah. When I solve it, I'll let you know.
Yeah, very good. Well, we've got a couple of minutes left, so I guess if you want to give our closing words, would you like I don't know what you're looking for companies to contact you if they want your services, or
certainly, yeah. You can contact us. You can contact my email. I'm sorry, I don't think I put it on a slide. My email address is just benf@wni.com. And I'll be happy to put you in touch with our numerous colleagues and we can talk about these solutions further. But yeah, feel free to reach out anytime. And I'm excited to see what we can all do together moving forward. I mentioned during the presentation that we're paying close attention to the health of our planet, right? I mean, this is where we live. And so ultimately the improvements we make on all the things we discussed today, it's going to help where we live. And I think ultimately that is our end goal. And in the process, if we improve our bottom line, awesome, that's great. And so we can work together and we can get there. And I hope, working with Weathernews, some parties are able to do the same.
Yeah, weather is a fascinating part of shipping. I guess most of us have barely even thought about, including me. I think so. Yeah, well, thanks very much. That's fantastic. So we'll send you an email out to the attendees. Now you've given us permission to do that. And thanks. And I shall pass back to Farah for the closing words. Cheers.
Thanks much, Carl.
Wow.
We'd like to thank our guest speaker, Ben Farig, and audience for today. If you have any more questions, we'll be sending contact details alongside a link to a recording of this video, which you can watch on our YouTube channel. Bye for now.
Cheers. Bye-bye.